Newton's second law of motion. Objectives: to understand Newton's second law of motion and to understand momentum with examples. We have already seen in the Newton's first law that a body does not change its state of rest or motion unless acted upon by an external force. In other words, we can say that the change in motion or acceleration of a body depends upon the force acting on it. But the first law does not show us how acceleration of an object depends upon the force acting on it, whereas Newton's second law gives us the relation between force and acceleration. If a slowly moving cricket ball hits a person, it would not hurt her much. But if the ball is moving at a high speed, it will hurt her severely. The difference in both the cases is the velocity of the moving body, that is, the ball. Now, if the person is hit with a tennis ball, the impact is once again less than that caused by the cricket ball. The difference in this case is the difference in mass. With the help of these examples, we can define a new physical quantity called momentum. The momentum, p, of a body is defined as the product of its mass, m, velocity, v. The SL unit of momentum is kilogram meter per second. Let us see another example to understand momentum. Take two marbles with the same mass. Hold the first marble at a height of 2 meters above the glass top of a small table. The marble has no initial velocity. Release the marble. It attains a certain final velocity and hits the tabletop with some sound, but does not break it. The other marble is held at a height of 5 meters. Its initial velocity is also 0. Now, release the marble. It attains a much larger final velocity than the first marble when it reaches the tabletop. This marble hits the tabletop and breaks the glass at the point of impact. Let us now take two marbles with different masses, that is, 10 grams and 100 grams. Both are released from a height of 3 meters, so that they have the same final velocity at the point of impact. We observe that the marble with greater mass breaks the glass top, whereas the marble with less mass does not do so. Hence, we infer that an object having more mass or traveling at a higher velocity possesses greater momentum. Now, with the help of momentum, let us understand the Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum in a body is proportional to the unbalanced force acting on it and takes the direction in which the force acts. Consider an object having mass, m, which is moving along a straight line. Its initial velocity is u. Now a constant force, F, acts on the object, which is uniformly accelerated. After time, t, its final velocity is v. The initial momentum of the body is given by p1, which equals m into u. And the final momentum of the body is p2, which equals m into v. Here the change in momentum of the body in t seconds is given by p2 minus p1, which equals mv minus mu. Therefore, the change in the momentum of the body in 1 second is given by mv minus mu by t, that equals m into v minus u by t. We know that the change of momentum in 1 second is nothing but the rate change of momentum. Hence, the rate of change of momentum equals m into v minus u by t, equation 1. According to the equation of motion, v equals u plus at. Therefore, a equals v minus u by t, equation 2. Substituting the value of equation 2 in equation 1, we get the rate of change of momentum equals ma. Equation 3. We have already seen that the rate of change of momentum is proportional to the unbalanced force. From equation 3, we can say that ma is proportional to the unbalanced force, which can be denoted by F. F is proportional to ma. This expression can also be written as F equals K into M into A, where K is the constant of proportionality. Now, assuming that a unit force acts on a body of unit mass, thus producing unit acceleration, we find the value of proportionality constant K to be equal to 1. Substituting this value of K in the above equation, we get F equal to M into A. This is the mathematical expression for Newton's second law of motion, which gives us the relation between the force acting on an object and the resultant acceleration produced in it. That is, the force acting on any known mass can be measured by finding the acceleration produced in it. Summary. The momentum p of a body is defined as the product of its mass m and velocity v. The SL unit of momentum is kilogram-meter per second. Newton's second law of motion states that the rate of change of momentum in a body is proportional to the unbalanced force acting on it, and it takes the direction in which the force acts. And Newton's second law of motion gives us the relation between the force acting on an object and the acceleration produced in it.